Today we are going to give you introduction of ASJade Smart Charging Solution and also some future development work we are going to take. And we are going to divide today's presentation into two sessions. I'm going to give you a brief introduction to ASJade's Smart Charging Solution, which is what we have today. And Alex Chu, for the second session, is going to give you some insight into how the technology we believe is going to develop and the future trend. And as Richard just mentioned, that we are going to take questions after the presentation. Okay. So first of all, let me give you a very brief introduction to ASJade. We were founded in year 2021. Headquartered in Taipei, Taiwan. We now have about 40 employees and over 75, even 80% of the population are engineers. So we are a very engineering oriented company. Our parent company is ASRock, and behind ASRock, our grandmother company is Pegatron Corporation, which is a multi-billion company. So although we are starting from software, but fortunately we can piggyback our mother and grandmother company on the supply chain and also global logistics. So that's why we can put our resources on the development side and do not need to worry about future hardware, parts, inventory things. And last but not least, we are MOBI partner, and also we are also a founding member of IT and Web3 blockchain. So that is just a few very quick facts about ASJade. So talking about our smart charging solutions, our product offerings covers a few different scenarios depending on what the user is going to use our products or technology for. In one word, we are offering networked hardware powered by a cloud platform. So our products portfolio can be divided into four basic elements: AC chargers, some people call it a destination charger, and the DC chargers, some people would call it fast charger or on the road en route charger. Management platform, cloud-based, and also complemented by a mobile app for EV drivers. So depending on how the user is going to use it and the size of the charging sites or the number of users you want to manage, starting from the very bottom of the chart for single houses where the EV owner is also the homeowner, probably just one or two cars to be charged, the AC charger plus a mobile app to manage charging schedule, to check charging status, to check electricity bill would be good enough. And moving upward for office building or multi-dwelling unit or for a community, you need probably a few AC chargers and the management platform where the committee need to understand how much electricity was consumed by which car and where the money goes and who is to build for that electricity, things like that. And moving even upward for commercial scenarios, for hotels, department stores, or hospitality outlets, convenience stores, auto dealers, or even service areas. When people want to stop only 10 or 20 minutes for a cup of coffee or just for restroom break, they probably need a DC charger which can fill their EV to up to 80% in 50 minutes. Then we're adding AC charger to the portfolio. And of course, for people who operate that network, they also need a management platform. So this is the whole picture of our product offerings. So let me a little bit more details. For the AC chargers, I just want to take, I don't want to spend too much time on these things that you probably have been seeing in many places in the world. Just to take some one example for the hardware, like the single phase AC chargers. And I just want to highlight some of the differentiation factors that we are adding into our products. For example, for the input, we have different voltage settings for North America, for Asia, and for Europe. In the future, we are going to add three-phase product as well. For the output, we are targeting on the very high end of this kind of AC charger. So for the US market, the maximum will be almost 20 kilowatt. That means when at full charging power, for just 1 hour of parking, you can add about another 50, even 60 miles of range to your cars. So that will be good enough if you are going to a shopping mall or you are having dinner at a hotel. And for the IP rating, which is on NEMA 4 IP65, that means you can, your hardware is very well protected. As you know, nowadays, everybody is talking about extreme weathers, very high temperature, and storms. So the hardware is very well protected. And so if you can see my monitors here, we are adding hardware health monitoring. So before the charger goes broken, you know it is experiencing something wrong, and you can take some proactive action to stop it from stopping working. IK rating, we are going to, we made the product to be very resistant to impact. So IK10 is probably one of the most highest standard in the industry. And for operating temperature, it will operate normally as at temperature as low as -30 degrees C and up to 55 degrees C. So from Arizona back to Alaska, it will work normally. So these are just some highlight of the hardware features. And also here, I want just to highlight that these chargers are built in with electricity meters. So with 1% accuracy, this is kind of meter that you can accurately check or measure how much energy was consumed. So this is, in some countries, this is good enough for you to use to charge your customers or consumers. And certifications, of course, for different market, the product is going to carry different certifications. So it will be used safely and legally in many different countries for different applications. So these are what you probably have seen elsewhere on other manufacturers' product, but we are also adding some different design DNAs to our products. For example, all our products are future-proof to protect your investment. So it is now shipped with OCPP. OCPP stands for Open Charge Point Protocol 1.6, which is the de facto standard nowadays. But in the future, when the new standard comes effective, the OCPP version 2.0.1, we can do over-the-air update so that your charger will stay up to date. So it won't be outdated. And because, as I just mentioned, it is in electricity meter, so you do not need to install another meter, which costs maybe another $100. So this hassle-free installation by adopting high precision built-in revenue grade meter will save space and save money and the installation cost, of course. And moving on, we are also adding more hardware monitoring sensors and monitoring ICE technologies, so that this charger itself, along with the management platform, is going to tell you if something is going wrong. So it will also predict whether this charger, the hardware, is going to be, for example, overheated, or the current or the voltage is dropping abnormally. So it will alert the owner, even the operator, to take some proactive actions, so that the downtime will be minimized And in the commercial cases, the revenue will be secured. You do not need to worry to wait until the charger is broken to fix it, and so you will lose revenue, and more importantly, you will lose customer loyalty. And of course, better protection of your asset against extreme weather, because we are NEMA4 rated, this which is probably the highest standard in the industry. So it will be protected against snow, dirt, raindrop, even direct water spray. And last but not least, the cables, even the charging gun cable, has been very well carefully selected, because if at a very low temperature, if the cable, the very heavy, very rigid cable was put outdoors for overnight at minus 20, 30 degrees C, it can be very rigid and you can hardly use it in the morning. But because we carefully selected the material, the copper wire, and also the plastic covering, so it will be still very usable, remain flexible enough for user to use it. So all these are just what we add into the element, the element we add into our products to make it more user friendly. So these are the hardware part. And talking about the management platform part, and for the basic and the advanced versions, you probably have also heard of similar things elsewhere. Like the basic version can do charger onboarding, and you can charge by scanning QR code, or you can use your RFID card, and it will send alert if anything goes wrong. For the advanced version, you can also manage pick card control, and you can do transaction data analysis. But we want to emphasize that for the premium version, we can do customizable service level by membership tier. For example, some people may sign up with higher monthly fee, so this kind of people deserves higher level of services, or dynamic load balancing, just like a flight airline royal customer loyalty program. If you are a gold member, a gold car member, you should deserve more power. You can fill in your car and in a shorter period of time. And of course, you can also work with other commercial film company, advertising company, to push notification by, and also not even advertising, also promotion. For example, if you want to promote your charging station at slow hours, like 2 p.m. to 4 p.m. when the least people are charging, you can do this with our premium version of management platform. So let me just share some of the features of the management platform. For example, for smart charging, when you install more chargers at one site, you are going to impact the grid. So using the smart function, you can either monitor the peak hour usage, or you can set the maximum power to be consumed at peak hours. Because in most countries, if you exceed the contract that you signed up with the utility, the penalty will be very high. So you can dynamically manage how much maximum power is going to be consumed by that single site if more cars are coming in for recharging. And also for the scenario that you have limited total capacity. For example, we just give you an example of total capacity of 12 kilowatt, and you have 3 charging ports. When 2 cars come in to charge, the platform or the system will distribute 6 kilowatt per car, so it will be evenly distributed. When the third car comes, it will do a smart decision to evenly distribute 4 kilowatt per cars. But when one car is going to be fully charged, let's say it has been charged to 90% of the total capacity. Depending on the car will drain a much smaller current, let's say 0.2 kilowatt. So the system will distribute all the other powers to the other cars with relatively empty batteries. So these are the features that you can manage. As I mentioned, you can manage which cars to be charged faster or at higher priority. You can do your own customer loyal program, and you can do differentiated membership privileges. And of course, when you gather all those data, you can do whatever analysis you want. For example, this is just one of the examples of the screenshot. For example, this chart, this pie chart and bar chart shows you the revenue and the utilization dashboard. So the network owner knows, okay, which day it can do analysis. Okay, maybe September 2nd is a holiday, so most people come here for charging, so the demand is much higher than weekdays, something like that. Or you can also do analysis across different charging types, different connectors. That will help you to decide which kind of charger or which kind of service you want to add, or if you need to increase your total capacity. And you can also monitor each charger's status. If anything, if one charger is unavailable at which site, you can also get real-time notification. And for power usage by site, for example, this is just an example to show you that, okay, at 1 p.m. in the afternoon, maybe people are coming from lunch, come back from lunch, so everybody has plugged in. So there is a surge in the charging demand. So you can decide whether you need to increase capacity or you want to add more ports. And for transaction summary, you can do analysis chart. You can see, okay, which site, which charger, which port has any transaction with how many cars during the day, during the week, and historical data. So the purpose of the management platform is to gather as much data as possible. And also we have some built-in intelligence to help the owner to analyze where to add more ports, whether your total capacity is good enough, or should you phase out this type of port and add another one. Or you can, it will, when the data, amount of data is accumulating, you can also decide whether you, where to add more ports. So transaction summary by site. This is what you can use to improve your efficiency or to reduce downtime or to increase customer loyalty. So this is pretty much the management platform features, but actually with all those data on hand, there are much more things to do. So before I hand the session to Alex, I want to also mention that for the existing system, this is what you probably have seen happening in some countries or maybe in your community. So in addition to draining power from utility, there's also renewable energy technologies like wind power or solar power. It will feed power into a community, a building, or even a single home for energy storage systems. So you need an energy management system, and you can use those stored energy either to charge your car, your scooters, your e-bus, or to power the buildings. But for the future, we think that we will explore more possibilities to let the power to go bi-directionally. For example, that means when solar or wind power are generated, it can be fed into cars, but for vehicle to grid or vehicle to home, that kind of case, A car can also be used as a power bank. So when power goes down, or when peak hour, the time of use price is higher, you can also use the energy stored in your car or in your energy storage system, feedback into grid to save cost, to save your electricity bill, or even sell it back to utility. And most importantly, nowadays, a lot of people are talking about decarbonization. And how do we know that all the energies we feed into our electrical vehicles are from green energy? Are they from fossil fuel power plants? So the traceability of blockchain would be a very powerful tool that we want to add into the entire power transaction trace. So for ESG and for integrated with its enterprise resource system like SAP and Oracle, we also want to integrate this whole system with corporate ERP and even for single home, for very environmentally aware consumers, we want to use blockchain technology to make everything transparent. So consumers and corporate users knows that when they are driving electrical vehicle, they are really riding on green energies. So that'll be for the next phase, what ASJade is going to spend more resources on. Okay. Before I conclude this session, I want to know if you have any questions. You can leave in the dialog box. And before I hand it to Alex, any questions so far? Good. Then I think I can hand the session to Alex.
Thanks, Richard. Okay, so I'm sharing my screen.
Good. Okay.
Right. Okay. So basically, I think Richard has outlined some of our corporate strategy and our products that are actually currently in our development. So in the second session, we are going to talk about how do we empower our EV charging network with Web3. So the use case listed here is roaming. Okay. Right. So this is the actual trip that I want to do. So before COVID-19, I used to attend Better World in Nuremberg. So imagine that if I want to drive from Nuremberg to Porto to have a port wine, right? So the overall driving distance is about 1,500 miles away. With the EV cars today, depending on the models, it's about like the range of your EV is most likely fall in between 300 and 350, something like that. So meaning that you will most likely be charging at least 5 times during the trip, right? So the problem that we are facing, especially for a foreigner or someone that are not used to travel around the country, is the choice of charging network that you want to subscribe. So this is a very common problem because right now, EV charging infrastructure is not like telecom, right? In telecom, if you want to travel between countries, then you can easily get roaming service, right? But for EV charging network, right now it is still very fragmented. So the trip is going to make us into the EV driver is going to fall into choice paralysis issues, meaning that I would want to survey that during my trip from Nuremberg to Porto, I would want to understand or survey or investigate myself that which charging network will be available to me, right? And of course, if you are driving Tesla, then that's much more easy. But today we are talking about only Tesla, but non-Tesla as well. So where should I plan my trip? Where should I stop for charging? So different EV charging network has different apps and also different payment methods. So this is some of the actual case that many people will be facing. So roaming is not something new. As I mentioned before, we are very familiar with our mobile phones. So we move from one country to the other country, we can choose our roaming package. So by roaming, which means that when you can actually charge your EV in a foreign network instead of the local network. So the main issues between local network and foreign networks is a trust, right? So this is the main issues that stop everyone from collaborating, because I don't know you and you don't know me. So if I provide charging service to your subscriber, how are I going to collect the bill or collect the money, right? So these are the main issues, the trust issue that's happening in roaming. And of course, we are not the first person who deal with this. So the three fundamental issues that we want to overcome in roaming is authentication. So these are the identity. So meaning that we want to understand who is actually doing the charging, and is it do the EV charger, do the EV owner has the correct contract, or if the EV charging station is legal or is legitimate to provide the services. Those things are identity, right? So everyone needs to be onboarded on the same network in order to understand each other, or at least everyone needs to be on an interoperable network in order to identify each other. The second trust issue that we need to overcome is authorization. So these are the issues that deal with entitlement and rights, right? So can the EV owners charge in Germany, for instance? Do we have a whole EU? You can charge at any place, any EV charging station in the EU. So these are some of the questions that authorization we'll need to deal with. The third one, I think, is the most important one, is the billing. The billing issues is one of the most of the important factor that actually hinder network operator from collaborating with each other, because they want to ensure that when the service is provided, we need to charge correctly and we need to do settlement, right? So these are the fundamental trust issue that we need to come in roaming. Right, as I mentioned before, we are not the first one who want to deal with this problem. Many people and many organizations have really realized that roaming is a requirement in future, right? So there are already many operators who try to do this. So among the four most popular protocols or foundation that doing this is OCPI, which is backed by EV Roaming Foundation. So you can implement OCPI protocol. This is an open source protocol, open charge point interface that allows you to interact with different EMSP, e-mobility service provider. Okay, so I assume that everyone is okay. I'll pause for a moment to kind of explain about the very typical ecosystem of a charging network. Right, definitely you have the user, which is the EV driver, and typically the EV driver is subscribed to a charging network, what we call e-mobility service provider. Okay, each e-mobility service provider will actually consist of several CPO, which stands for charge point operator. A charge point operator operating different charging station, which has many charge point or EV supply equipment installed. Right. So in many countries, the EMSP provider is also a CPO. For instance, Blink, EVgo. These are all EMSP player, but also act as CPO. But some countries, in some areas, these roles are actually separated. So looking at this diagram, if you want to do roaming, there is obviously no problem on local network because everything is settled. But when we want to roam to foreign network, there's different party here. We try to make sure that everything is okay, right? So this is where these protocols are doing. So they are all handling things like authentication, authorization, and of course, billing and settlement. So OCPI is one of the protocol that you can adopt and implement it. OICP is one of, I think, very popular one, HubJack, and also EMIP, which is supported by Grief. These are very popular infrastructure or provider or platform provider that's enabling roaming of EV charging network. And the other is Open Clearinghouse Protocol, or CHP, which is also popular in Europe as well. So one issues on this is that right now they are all kind of like centralized or targeted at just although they are operating by many members of foundation, they are still kind of like centralized kind of platform. Okay, so what we're trying to do today is that we try to understand that how we can utilize MOBI Web3 infrastructure in EV roaming. I think if you guys have already attending this lecture, that you must be familiar with this diagram. This is the MOBI Web3 infrastructure proposal, which consists of the ITN and Zootopia, where ITN is actually the date registry, and the Zootopia is actually on the application layer and the service layer for the ecosystem. Okay, so how are we going to use MOBI Web3 infrastructure to actually empower our EV charging network? So as an EV charger solution provider, we think a lot about this because obviously the Web3 is actually advancing, and many countries or many regions, especially EU, has invested a lot in the blockchain infrastructure. So eventually we'll see that everything involving in this infrastructure or EV infrastructure is moving toward automation, right? So obviously the Web3 infrastructure is one of the solutions for to enable those automation. So again, we understand that we need to deal with identity, entitlement rights, and billing. So when we apply MOBI infrastructure, we use decentralized digital identity with ITN, right? So this is where every party in the ecosystem on board. So everyone will have a unique ID or the DITs, so that we can understand each other, and this also enables us to conduct secure communication based on our public and private keys. Okay, so after solving the authentication or identity issues, we now comes to the second important things, that is the enhancement and proof of transaction with VC. VC stands for verifiable credential. So these are the key important pieces that allowed us to glue everything together, right? So in our in the previous solution, everything is done, of course, in although it is an open source protocol, everything is basically done in a data exchange and a proprietary manner, right? So in the Web3 infrastructure, especially in MOBI or ITN proposal, we are actually adopting standard instead of creating a standard, right? So we do create some standards based on interoperability, but the fundamental standards of the DITs and also VC are actually coming from the W3C consortium, right? So how do we going to use VC in order to enable the roaming service? So the use case is what I'm going to illustrate. So when we look at this use case, everyone is already onboarded on ITN, right? So everyone will have a DIT. So when you subscribe to EMSP, the EV owner actually establish a contract with the EMSP, right? Okay, you're subscribing a package or a plan, right, for your EV charging. So the EMSP will actually issue a verified credential to you. So in today's, unfortunately, although our car has the ability to connect to the internet, so right now we still haven't reached a consensus or standard that every car has a built-in SSD. So right now we are depending on the EV owner's phone as a SSD. By the way, SSD stands for self-storage digital twins, which is actually an agent that acts upon you that can establish VC and also store the credential. Right. So in this scenario, when the user subscribe plan or with the local EV charger e-mobility service provider, the EMSP actually issues a credential, a VC, to the EV owner, right? Which is stored in the mobile wallet. So these are the contract for the EV charging. Right. So the EMSP itself, because EMSP actually has the own platform to manage multiple CPU, right? Because the purpose of the e-mobility service provider is to actually enroll as many CPU as possible, so that they can give access or they can have more subscribers to the EV charging network. So they have their own platform that do settlement and everything, which is connected to the CPU. Okay, each CPU, again, like what we have demo, like what Richard has demoed just now, we will have a cloud management platform, which are known as CSMS, Charging Station Management System. That is actually used to manage all the equipment, which is the charge, the charge point, or what we refer as EVSE, EV supply equipment, in a charging station. Right. So when you want to make sure that everything installed is legitimate, at the same just like a EV owner subscribing to a plan, right? A CPO need to prove that he is actually part of the EMSP, right, of this provider. And every charge point need to also prove that it is part of the property or asset of the CPO. So in this case, the EMSP participation and EVSE ownership, again, is also binded or also validated by VC, verified credentials. So the EMSP, the e-mobility service provider for a specific network, will actually issue the VCs to the CPO that is joining his network. This is a one-to-many relationship, right? Because as a CPO, I can join many e-mobility service providers in order to maximize my revenue, for instance, or maximize my customer base. And again, each CPO could manage many charging stations across different areas. So for each charging station, there's a relationship that stated that this asset is belonging to certain CPO, right? So a verified credential is issued by the CPO and installed and stored on the EVSE as a proof that this EVSE is actually part of the charging point operator. Right. So this is the first step. The way that everything is contract and everything is verifiable. Now, so this can only be happen if everyone is onboarded to the DITS registry, right? Remember that we are not talking about just data. We are talking about verifiable credential, meaning that the credential that's stored in each of these systems are able to actually validate it by a specific service. So this will enable the trust between different parties. Okay, so right now we haven't talked about when the charging actually happens, right? This is just a fundamental setup. So the membership and every remember we talk about authorization and entitlement. So we understand that you have a contract, and the contract allows you to do certain things, and also the CPO and EMSP, they also has a formal contract which is stated in the verified credential, and each of the EV SE has also something that is related to the CPO. So this is the first step. Okay, in the second step, when remember that the EV owner won't be actually interacting with the EMSP. When I was driving from Nuremberg, for instance, let's stop at Paris. So I won't be interacting with the EMSP actually. What I will most likely interacting with is the charging station, right? So we try to make this very realistic, that also when we're driving a typical car, when you reach a gas station, we just try to fill the car, right? So the first thing that we interact is not EMSP, it's actually the equipment itself. So when a driver actually arrives at a charging station, so you want to charge, right? So let's say that it says, in today's in the real life situation, you're most likely be scanning a QR code, something like that. Let's say that you scan a QR code that provides some information about this charge point. So at this point, the EVSC actually reply you with a verifiable presentation of the EVSC itself, right? So this gives you some information about this EVSE and also the CPO and also the EMSP. And of course, in general, we will also put in the price, for instance, the tariff, for instance, for you to actually agree or consent whether you want to charge at this foreign network. Okay, let's say that right now we are dealing with the happy path. So we have no choice because I only have 2% electricity left. So what we are doing is that I will accept this is verified, and I will accept that I will be charging at this tariff or at this price at this station, right, in this network. Okay, so but after you agree, you request a charging session. The foreign network operator needs to understand that when I provide you the service, how am I going to charge you, right? So we are not talking about the instant credit card payments. Right now, we are talking about roaming service. So recall what we are right now, what the roaming service that we are having today in our mobile phone is that when you do a roaming service or you do a call in the country with a roaming service, you are going to charge, but when are you going to pay? You are going to pay after you return to the country, and it will be included in your local network phone bill, right? So this is how it works in roaming as well, right? So when you say that you're requesting a charging station, charging session, then the foreign network need to understand that when I provide this service to the EV owner, I have no risk in collecting the payment, right? I will have a party or another EMSP that I can collect the money from. So which is why it will ask for proof for the valid contract from the EV owner. So at this point, remember that the EMSP in the local network has issued a verified credential, which is a contract of this EV owner with the EMSP, right, in the wallet. So at this point, the EV owner will need to present, or the SSD will need to present the contract to the EVSE. Right. So by this is actually showing the EVSE that, okay, I am subscribed to EMSP A in my local area, and my plan is I can charge it France and also Germany and Spain. So these are my term, and then so these are presented to the EVSE, and of course everything is verifiable, meaning that behind the scene, there will be a service that is actually validating this identity and authenticity of this document through the Sitopia nodes, and also checking on the ITN registry. So after these are validated, then we understand that, okay, we have after parameters are granted that we can collect money from ENSPA, right? So the EVSE is good to go. It will release the charging connector and allow the charge session to carry on. Okay, I'll briefly pause here. Any questions?
Yeah, Alex, thanks. So we have 10 minutes. Do you have more slides, or do you want to?
Yeah. I still have the final pieces, which is the most important one, is billing.
Okay, let's talk about that.
Okay, quickly. Let's continue. Okay, so assuming that the charging, everything is done right, so this session is completed, then the transaction itself is actually issued as a verifiable credential to the EMSP. Remember that we are actually taking services at the EV charging station, right? So the charging station, if you recall that there will be a meter in the charging station. So it will record the amount of energy that's being consumed and as a tariff. And remember that the EV owner also presented a credential during the process. So with this information, these are all packed together and issuing as a verifiable credential to the EMSP of the foreign network. So because the CSMS, which control the EV charging station, it will have SSD that allow the CPO to actually issue a VC to the EMSP. So the EMSP, the foreign network EMSP, is now in hold of the transaction verifiable credential. Okay, so this will act as a billing proof. Okay, so the billing credential that allow the foreign EMSP to collect to bill the EMSP in the local network, because the verifiable credential is actually something that can be verified, and also the EMSPA is actually the local network e-mobility service provider has all the record that consumed by the EV owner, because they have a contract, right? So they can cross-check that everything is okay and the settlement is done. Okay, so to this use case, I think by far this is one of the more detailed use case that you'll see in many seminars. So through the use of verifiable credential, we are able to make the whole settlement process and also authorization process much more easy. And with the decentralized identifier, we are able to actually identify everyone or multi-party on the whole roaming network easily. So I'll finish off with another view of the how everything works together, right? So remember that at the lower level is the DIT registry, which actually holds the identification. These are the trust anchor, so that we know everyone have DITs and everyone have a key that we can use to encrypt or verify their identity. And on top of the service, there are multiple nodes that provide the service. So today we are talking about the EV charging service node that provide many features, just like roaming and also onboarding all the parties to the ITN. Right, these are all done to the EV charging service node. So everything that happening. Remember when I say that it need for instance, the EVSE need to verify the contract of the EV owner. These are done through EV charging service node. You can just ask the service charger node to actually verify that the EV owner is entitled to do this charging. So everything is done in this manner. Okay, so we believe that in future, because the verified credential is not something that that is proprietary or only resides in just a centralized system. because we can have multiple service node, it can also be decentralized EV charging service, and each servicing node providing common service as well as some caveats such as reservation, for instance, other services. So we actually make the roaming much more easier for different players in the ecosystem. Right, that's it for today. Hopefully it's not too technical.
No, this is very interesting. Thank you, Alex and Richard. Any questions for Alex and Richard? We have about 4 minutes left. Alex, are you in any kind of stage with regards to deploying this architecture with your current product lineup?
Okay, yeah. So as Richard has mentioned that I think we have following closely with ITN development on this. So we are still at experimental stage, but the key thing is that for our EV charging service equipment and EV on the CMSS or the cloud management platform, this will have MOBI SSD or ITN SSD integrated. Sorry. The correct terms right now is called Zootopia SSD, right? Yeah, integrated in this system. So we make sure that it will work with the ITN network. But in order to actually have this whole ecosystem to run, I think a pilot is definitely required. So of course, if anyone in the community is interested in launching some pilots with this kind of technology, do let us know.
Okay.
Yeah.
Any other questions for Alex?
Let's see none. Yeah. So the interesting area of this is that the VC is actually evolving, right? So there's a basic format there, but we will still need to have a group of people to discuss, or someone in the working group to come up with a more practical or applicable VC to describe everything. So that I think that pieces need more development right now.
So if we were to do like a real world pilot, right, with real charging point and real the application in 2 different countries, let's say, what would it take?
So let's say, first of all, the EVSE itself, right, need to have SSDT, right? Okay. Because it will for the management platform, it doesn't matter, because we can host a platform and then allow the EVSE to enroll to the platform. So this can be managed by the CPO. Right? Okay. Yeah, and then the other thing is that the apps, this can also be done easily, because the apps is actually something that you can incorporate easily. So the only things that missing is right now the mobility service provider will be willing to do that. Right, because in many countries, like in Taiwan, there's not a very clear difference between EMSP and CPO, right? Because most CPO, because Taiwan is a small country, so most CPO is actually EMSP. They are operating on the same platform, so there's no difference.
So we should really talk about, I mean, in the future, about how to deploy SSDT inside an EVSE, right? Charge points.
Yeah. So that
do you see a lot of challenges to do that?
I would say no, because this is more or less the willingness for the EVSD developer to incorporate those. Okay. Because right now, because of the OCPP and all those things, the hardware of the EVSE is becoming more powerful. Okay. Right. If you look at the previous generation, then it might not, because previous generation most of the China does not need any connectivity or OCPP supportability, right? But yeah.
All right, we're out of time. Thank you, Richard and Alex, for your great presentation. The video will be available in Mobi website in the next couple of days. So if anybody wants to share it with your colleagues. If not, then thank you all for joining and see you next time.
Right. Thank you. Thanks,
Thank
everyone.
you.
Thanks all.
See you.
Thank you. Bye.
Bye.